Energy is the basic requirement for everyday activities in various spheres of life. It is a crucial input in the process of economic, social, and industrial development. This input energy is derived from various sources like electricity, coal, oil, gas, wood, agricultural waste, and water, etc. However, except water, other sources of energy are being consumed very fast and are likely to disappear soon. In order to preserve these sources, renewable sources of energy have to be utilized, like energy from the sun, wind, water, heat from the earth, etc. Among these sources, solar energy is the most versatile, abundantly available, and inexhaustible. Presently, it is used for various applications such as solar cooker to cook food, solar street light to give light in the streets, solar pump for irrigation purposes, solar cell operated radio, solar lantern to provide light in the house, solar still for getting the distilled water, and solar water heater for heating water. In India, most of the time the sun is available and the density of solar energy available is 4.5 to 7 kilowatt hour per square meter per day on a clear sunny day. The most promising and feasible application of solar energy is in the area of water heating. Solar water heating, especially at temperatures below 100 degrees Celsius, is a simple technology as well as easy to develop and fabricate with almost no running and maintenance costs. Commonly used solar water heating systems are thermosiphon solar water heater, forced flow solar water heater, and solar water heater with heat exchanger. In thermosiphon solar water heater, there is a collector connected to insulated water storage tank and connecting pipes. The heart of the solar water heating system is the collector. The collector comprises of front glazing of toughened glass, blackened metallic absorber with thin riser tubes, insulated with glass wool, and held in the collector box. Let us have a glance at the manufacturing process of the collector. In the beginning, a very thin copper sheet which is blackened with selective coating, is measured, marked and cut as per the required size. This is followed with grooving. The grooves are made for fixing of riser tubes. The grooved sheets are assembled one by one on the mount, so as to make the standard size of the absorber. Then the riser tubes and the main tubes assembly is placed on the grooves of the sheet and clamped for tightening it. The riser tubes and the absorber are soldered for a good thermal and mechanical contact. Thereby, the riser tubes are firmly attached to the absorber sheet. The absorber sheet is coated with black coating such as black chrome so as to absorb most of the solar radiation falling on it for heating the water. The collector casing is an enclosed metallic box in which the insulating material like glass wool is spread throughout the box. So as to minimize the heat losses from the collector system. The glass wool is covered with thin aluminium foil. After covering the glass wool with aluminium foil, the absorber sheet is fixed upon it. It is covered with toughened glass so as to protect the absorber plate from atmosphere, external foreign bodies, and to transmit solar radiation on to the absorber plate. After that, the frame is fixed. Now, let us see the working principle of the solar water heating system. Solar water heating system consists of water storage tank which stores the normal water at the bottom and the hot water at the top. The insulated pipe for carrying hot water is connected from the collector to the top of the water storage tank. The pipe carrying fresh water is connected from the storage tank to the lower side of the collector. The collector is the most important component of the solar water heating system. The collector consists of main pipe, blackened absorber sheet with rising tubes, which are covered with glass. The solar radiation passes through the front glass and are absorbed by the black absorber surface, thereby generating the heat. This heat is transferred to the fresh water coming from the storage tank. This water goes to the riser tube through the main pipe, and the heat generated by the absorber is carried by the water present in the riser tubes. The movement of water is caused by natural thermosiphon phenomenon. Water heated in the collector rises to the tank due to its low density and is replaced by the fresh water from the bottom of the water storage tank. Continuous circulation is thus formed, which heats the entire water. The hot water can be drawn from the hot water storage tank as and when required. The insulated pipe carries the hot water connected to the storage tank to the utility place. This system is most suitable for domestic purposes. This type of system can be extended up to the capacity of 5,000 liters per day by series and parallel combinations of collectors. If the capacity exceeds this limit, forced flow solar water heater system is used, in which a pump is introduced. In such cases, electrically operated water circulating the pumps is connected in the pipeline carrying cold water from the storage tank to the inlet of the collector. The pump circulates the water between the storage tank and the collector, and the water gets heated up. When solar radiations are not sufficient to heat the water, an auxiliary heating arrangement in the form of electric heater is provided in the water storage tank. A separate fluid like oil is used in the collector system under certain conditions, such as when there are lots of impurities in the water which damages the collector. The heat of this fluid is then transferred to the water through the heat exchanger. For receiving the maximum solar radiation, the collectors are always kept at inclined position facing the sun. A maximum use of solar water heater is in the winter season. The inclination is kept at 15 degrees more than the latitude of the place, and it's facing the equator. Here are some of the applications of the solar water heating system. In the domestic sector, hot water is used for bathing, washing clothes and dishes, etc. We talked to a housewife using this system. According to her, we save on electricity charges because we have not installed a geyser, and we get the hot water from our domestic solar water heater. We have installed the system 4 years back, and till now it is working satisfactorily and there is no problem. Even when the weather is rainy, then also we get the hot water supply up to 1 day. We use the hot water from the system in early morning hours for bathing as well as for washing clothes. In hostels and schools, where a large quantity of water is required, the solar water heater are used to meet this hot water requirement and to save the expenditure of electricity. In hospitals and clinics, hot water from the solar water heater is used for sterilizing the syringes, apparatus, and other related activities. In industrial sector, a large quantity of hot water is required for boiler, etc.
We have a system which is very different, which is a very varied demand. We have a 3000 liter system installed on a guest house. We have a 1000 liter system installed in a cafeteria. Then we have 3000 liter system installed in a laboratory area. Then we have a 3000 liter system for preheating soft water to boilers. We have 4 boilers, out of which 3 boilers we use very regularly. And the soft water which is preheated by the solar water heating system is fed to the boilers. Now through the boilers we try to attain a temperature of around 180 degrees. Now what happens is, normally if we take ambient water, the temperature is going to be around 20 degrees, 25, 26 or so. But now we get water at around 60 degrees and in summers even up to 70 to 80 degrees. That shows that from 26 to 70 degrees, that much amount of heat which we have to generate through diesel is not required. So we do a considerable saving in diesel by using preheated soft water.
The solar hot water systems are gradually becoming more popular because of its various benefits. The major advantage is that solar energy is locally available and free of cost. These systems do not require extra space as they can be mounted on the rooftops. Moreover, the solar energy does not lead to pollution. Thus, solar water heating system offers immense potential for energy conservation.